Hi and welcome to this video on Venn diagrams made easy. Now Venn diagrams show relationships between different sets, and sets consist of different elements, and these elements within a set don't have to be in a particular order. So in this diagram, this Venn diagram, we're showing this blue rectangle, and within that we have this symbol here which is the universal set. So this describes all the elements within this blue rectangle. Then these circles are set A and this is set B. Here we've got A intersection B. This upside down U means intersection, and that's where they overlap, and this equals an empty set. So this symbol is an empty set. So what we mean by A intersection B equals an empty set is that they don't overlap. There is no intersection. Here we are actually showing an intersection, so A intersection with B, and this describes this overlap. So this shaded area here is A intersect with B. So set A overlaps with set B, and this area A intersection B. This U is the union, or we can say and B. So A union B, A and B. So this shaded area where A and B are both shaded is A union B, or A and B. This A with a little line or a comma there, or a little apostrophe, this is the complement, A complement. So this means not A. So the area which is not A within that blue rectangle is this shaded blue area. So this is A complement, this blue area. Okay, let's go over a simple way to do shading of these different areas. So if we want to do A union B complement, so this means A and not B. Okay, so first of all let's just get A, so that's just this blue circle, then B, which is the area outside B, and A union not B then would be A and the area which isn't B, so it will be all this blue area. Okay, A intersection with not B. So remember, not B was all this area outside B, and A the area inside A. So A intersection not B is just this area here. So where they both overlap. Not A intersecting with not B. Again, it's all the area outside of A and all the area outside of B. So it would be this shaded area in blue. So not in set A and not in set B. Not in A union B. Again, that's the same as the one we did earlier as this. And this is described by De Morgan's law, if you want to look that up or Google that. Not in A intersecting with B. So this is the area A intersecting B, so all the area outside of that is not A intersecting with B. As we said, Venn diagrams can be used to sort out elements within a superset. So here we've got a superset which is these numbers, which don't have to be in any particular order. Then our set here is multiples of 3, and our second set is multiples of 5. And then we just go through and place these elements or these numbers within the superset into these different sets. So 3 is a multiple of 3, 30 is a multiple of 3 and also a multiple of 5, so it will be in this area here, which is multiple of 3 where it intersects with multiples of 5. And then just see if you can go through and put them in their respective places. 17 doesn't belong in this set or this set, so it lies on the outside, and the same with 23 and 2. So just stop the video and see if you can place these elements in their particular sets. Okay, here we've got a Venn diagram of people who watch football and rugby. So how many people watch rugby? So the rugby set is described by this circle, so it would be 18 plus 11, 29. Students taking maths and English, described by this Venn diagram, so these people take maths, these people take English. Here, these people take maths and English, both subjects. How many students are not taking both maths and English? So these are the students taking maths and English or not taking maths and English. 18 plus 14, 32. Quite a difficult question to visualize, so I'm just going to go through this with you. Venn diagram describing a number of students. 21 students do maths, and then we have the science. 18 do the science club. If there's a total of 29 students belonging to only one class, okay, how many students belong to both classes? So we're trying to work out this section, this overlap. So it's 21 minus the intersection plus 18 minus the intersection equals 29. Then bringing all the terms together, we have 39 minus 2 intersection equals 29. So 2 intersection equals 10. If we take the 39 to the other side, that's 39 minus 29 is 10. Okay. So 2 intersection equals 10, so the number in the intersection is 5. 10 divided by 2, 5. So it would be 5 in this position here. So in this written question, we've got 150 students in a class. 85 did maths, 70 did English, 50 did both subjects. So first of all, we start here at the bottom at both, okay, where the overlap is with the maths and the English. So maths intersect English, do the overlap first and write down 50. Okay, and then we can carry on. So 85 did maths. So the maths only is 85 minus 50, which is 35. So put the 35 with the maths. And then let's carry on to do the English. So the English only, it would be 70, because 70 did English, minus this 50, which is the overlap, which is 20. So our final diagram, our final Venn diagram would look something like this. Yep. What about students that don't do maths or English? So this would be like the 150 minus the 35 plus the 50 plus the 20. So that in brackets, and we get 45 students on this outside, which is the number that don't do maths or English. Venn diagrams, you can also be given 3 different sets which overlap. So here in this question, we've got 100 students, 20 took PE, 31 took biology, 42 took English, 9 took PE and biology, 10 took PE and English, 6 took biology and English, and 4 took all 3. So first of all, we look at this number here, which is the overlap of all 3. Okay, and then we'd write that there. So this area here is the overlap of all 3. So that'd be 4. So fill that in first. Okay, and then we go to this one. 6 took biology and English, so we've got our 4 already in there, and we know 6 took biology and English, so that would be 6 minus the 4, which is 2. So 2 goes in this area here where the overlap is with biology and English. Then we just follow up here. 10 took PE and English, so this is the overlap with the PE and the English. We've already got 4 in that area, in that overlap. So to make it to 10, we need another 6. So 6 it goes in this area. So just continue, and we get this as our final Venn diagram. There is a distributive law of sets, and the distributive law, one of the laws says that A union B, when it intersects with C, equals A intersection C union B intersection C. The proof of this, let's just go over that. If X belongs to, so this means belongs to or is an element of, so if X is an element of A and X is an element of C, or X is an element of B and X is an element of C, then in this first case, X must be an element of A intersection C. So if it's an element of both A and C, it's got to be in that overlap of A and C, A intersection C. And in this second case, if X is an element of B intersection C, so if X is an element of B and X is an element of C, X has got to be in that overlap of B and C. And then X is an element of A intersection C union B intersection C, which is this in our right hand side of the distributive law of sets.